A very good afternoon, all of you. Welcome for this extension lecture session. So today we have extension lecture on your elective paper A. That is basic electronics. No, we have two electives. One is material sciences and another one is basic electronics, right? So for that, sir, he came. He is Dr. Abdul Hamid. So he is a assistant professor in Koti Women's College. So he came for to give the fine lecture, good lecture. So he is also our counselor in our PG session. He is taking first year and second year classes for PG counseling classes. Okay. So you are very lucky to listen properly. It is very useful to your coming exams. You have from 18th onwards, you have exams. Then you will get a little bit of gain also, knowledge gain, right? Okay, now I am handovering this session to our Hamid sir. Okay, thank you.
Good afternoon, all of you. So myself, already madam introduced. I'm Dr. Abdul Hamid, working as assistant professor in now it is Women's University. Okay. So today we'll see about our paper, that is electronics, basic electronics. So we are not going to see in detail, but initially we'll see what is electronics and why we required all these things. Then we'll move to, at last we'll go for some topic which you have in your syllabus, like power supplies, that is about rectifiers, we'll see. Okay. And if you see about electronics, so electronics, in the name itself, you have electron. Okay. In the name itself, you have electron. So this word electron actually come from the, otherwise we can say that it is originated from the word electron. Okay. So whenever the electron is under the influence of any external force, like it may be electric and magnetic force, it is going to be do something, like means it is going to be moved in any direction like that. So basing upon these movement of electron, so the electronics have been evolved. So if you see the electronics from the starting to till date, if you see how it has been changed. Okay. So after the invention of these semiconductors, a lot of change has been occurred throughout globe. So after the invention of the semiconductor, a lot of change has been occurred in our life also, because day-to-day life we are changing something. So you people will using all of you electronics, but you may be not knowing in detail about that. But after invention of these semiconductors, it has been changed a lot. Okay. So before the invention of the semiconductor and after the invention of semiconductor, there is a lot of change has been occurred in our lives. Okay. So if you see how it has been changed. So previously, before the invention of the semiconductors, we used to have like a vacuum tubes we used to have. Okay. Vacuum tubes. So these vacuum tubes, again, this is also, it is nothing but comes under electron. But what happens means this vacuum tube is filled with certain gas, and it is having its own mechanism. And also it is going to be occupies a lot of place, each vacuum tube. So the electronic circuit, whichever it has been made with the help of this vacuum tube, it is going to be occupy a lot of size. If you see the first generation computers, if you see, so the first generation computers, they used to have a bigger in size, not like your computer or some other thing, almost a quarter of this room you are going to be have. And even we used to call that as a computer, but it used to perform certain small operations like simply the addition or subtraction, some like that, or simple operations it used to perform. Even it is occupying a big in size. So that is what one of the electronic circuit which is made up of with the vacuum tube. Okay. So that is first generation computers, which is made up of these vacuum tubes. Then after the invention of this semiconductor has been done, so we can say that the era has been started after the invention of the transistor. So before the invention of the transistor, we used to have like what we call, they have invented the semiconductors, like, semiconductors, which is having the conductivity in between the insulator and conductor. So insulator means it does not allows current, whereas the conductor means which allows the current. Whereas the semiconductor, if you take, so which is having the conductivity in between these two. In between these two means in between the insulator as well as the conductor. So this semiconductor, as it is having the conductivity in between these two, so it can be utilized in any manner. Means either we can use this as an insulator in some manner, and we can use this as a conductor in some manner. So after the invention of the semiconductor, so there is a lot of changes has been done, as I said that. So we can say that the transition era, wherever it has been started, from the transistor era, a lot of changes has been occurred here. Okay. So this transistor, it has been invented by 3 scientists at the starting in the year of 1948. The year of 1948, the transistor has been invented. The scientist names called it as John Bardy, Walter, and as well as the Shockley. These are the 3 scientists who invented the transistor. For that, they have awarded the Nobel Prize in the year 1956. In the year 1956, this Nobel Prize has been awarded for the invention of this transistor. So once the transistor has been invented, so then after you have got, they have another era, we can say that IC, all you may be knowing, IC means integrated circuits we are going to be called. Once the invention of this IC has been started, so again, the changes, whichever it has been occurred, a tremendous changes has been occurred, and that too in very fast manner. So after invention of this IC has been invented in the year 1958 actually. 1958 it has been invented. So IC means, what is this? Integrated circuit. What do you mean by integrated? Different components we are putting together. So here we are making different components together, and it is to perform a different operations. Like in this IC, initially they has integrated like a number of transistors, that too very low, around 10 transistors they have put together, and they made some IC they have been made. And that IC has been working for any other thing. Suppose if you see the example IC integrated circuit, one of the example, if you see, like if you have any TV remote, okay, TV remote if you are having. So this TV remote, if you take, so what it is going to be performed? If you want to change any channel, you'll be using that only. If you want to change the contrast or color, if you want to increase the volume or decrease the volume, otherwise, if you want to, what we call set a time, okay, set a time that after 1 hour it is to be stopped, like that. Means so many operations it has been performing. So in the TV remote, if you observe, it is going to be have only one IC it is going to be have. We don't have any different things like for changing the channel, you don't have any electronic component, one separate component. For if you want to change volume, you don't have any other. All these are going to be fabricated at one place, that is single IC, and that single IC it is going to be have performing a lot of operations it is going to be performed. Like as I told that is one example. So you have daily applications, you have so many applications. Okay, so this IC era also, if you see, so initially we can say that this IC, it has been, we have what we call different integration, like different integrations, we can say that. Initially, we have a small scale integration. Small scale integration means only some hundreds number of components we are going to be put together. Hundreds of number of components means you may be having some number of transistors in that different like gates. You know, the gate is nothing but it is also a semiconductor device. Transistor is also a semiconductor device. So all these different components we are going to be put together. So at the starting, we used to have some very short, as I told, that some 100 numbers of components are put together, and they formed. They called it as a small scale integration. They have been called. So then after this middle scale integration has been come. So this middle scale integration is nothing but it is going to be have some thousands number of components has been put together, and they have fabricated like one chip, otherwise one circuit, integrated circuit we are going to be called. And those many number of components, it is going to be perform a lot of things it is going to be performed here. And then after you have like a very large scale integration. So very large scale integration means you'll be having some lakhs of components together. But if you see the size of that IC, it is to have very small in size. Okay, very small in size. And how it is going to be put together means we have separate formula for that one. By using the Moore's law, we are going to be put together all these components together, and they are going to be perform all these operations. So nowadays, as you are using, that is what we call, you are using a mobile phone. So if you are using a mobile phone means it is consisting of what? It is going to be consisting of processor. Okay, processor it is going to be consisting. The main heart of your phone or any laptop or other any electronic circuit, we can say that is the processor you are going to be have. So the processor nowadays, if you see, if you are buying a mobile now, so after 1 year, it is going to be change a lot of changes you are going to be get, like new models you are going to get. What are the models means? Like you may be having its own specifications. We can say that the processor speed we are going to be called. So it can be measured in terms of like gigabytes or different we have. So similarly, you have the memory in that one. Okay, memory is also nothing but that is a semiconductor device itself only. Like you will be having two types of memories you are going to be have, like RAM or ROM you are going to be have. So one is permanent memory, another one is a accessible memory you have. So like that. So if you see with the help of this VLSI, that means very large scale integration, some number of lakhs of what we call components we have put together, like transistors and all those we are going to be put together. We are going to be make a lot of things we can do with the help of mobile. If you see, we can, it has been replaced all the things, even it has been replaced your laptop or radio, all those things, it has been replaced with the help of that only. Why it is happening means after the invention of the semiconductor, whatever you are going to be have, this VLSI is not VLSI or whatever it may be, what we are putting, we are going to be put together all the semiconductor components together. Okay, so that is also a semiconductor device only. So this much importance you have that with the help of this what we call electronics. So in this VLSI technology means we have like a processors like a 32-bit, 64-bit, and nowadays we have the microcontrolled and all those things we have. So all these comes under the what we call semiconductor devices, like which we call it as the electrons we are going to be called. So this is how the things it has been after the invention of the electronics has been done. So now we'll move to actually some topic of your what we call rectifier. Right. So we call it as a power supplies. Power supplies we are going to be called. So under this we have like a rectifiers we have. Okay. So in general, what is rectifier? Before going into see what is actually rectifier means, simply what is the meaning of rectification? Rectification means general. I'm not talking about any science or some other thing. Correction or some other thing. So you did something. So you say that someone said that is having, it's wrong. So what you are going to do, you have to rectify that thing. Okay. So that means you want to remove out the unnecessary thing. We can say that unnecessary thing if you want to remove. So that you are going to be removed. Right. Similarly, here also, we have in the rectifier also, we are going to be remove which is unwanted for us. So generally, why we do this rectification and all those things means, so nowadays you are using so many electronic devices. Okay. So these electronic devices, you require certain voltage. Okay. You require certain voltage you require. So that voltage maybe varies. So if you see your mobile phone, you have a charger. Okay. Charger if you take. So what amount of voltage it is required to charge your mobile? Have you seen? Everybody is having mobile with you. Have you seen? No, I'm not asking about current. Voltage. 1.5. Around 15, 17, depends on the size of your battery. Whether it is required 15 volts input or 20 volts or 10 volts we require. And that voltage, what type of voltage it is required? It is a DC voltage. Okay. So you require a DC voltage. What do you mean by DC? Direct current. So, but what type of voltage we are getting into our households? AC voltage you are going to be getting. AC voltage you are getting. Right. So what do you mean by AC? Alternating. That means what actually it means? Sine? Yes, exactly. So this AC means, as we call it as an alternating. AC voltage means we represent. We represent with a sinusoidal wave. Right. So DC means direct current. What is the symbol? Have you seen? In your mobile charger, the symbol will be there. Have you seen that one? Any one of you? It is a this symbol, it is consisting the voltage, how much it is there, as well as the current specification also, whether it is required 1 ampere or 0.5 ampere or 1.5 ampere. So this is what we require. So nowadays, almost all the household things, the electronic circuits, whichever we are using, they require DC voltage. Okay. Even this DC voltage, you can get with the help of batteries also. With the help of batteries. So if you have certain electronic circuits, they may work with the help of batteries. Suppose if you have a watch, okay, so you have a battery that is also going to produce a DC voltage only. Okay. So otherwise, if you take the batteries of AA size or AAA size, so they also produce the DC voltage. So why can't we use those batteries directly to charge some other thing? Why can't we? Yes, that may be one reason. And one more thing is, if you are using these batteries, so for every circuit, whichever it is required a DC voltage, it may be expensive. It may be expensive. You see, nowadays you have electrical vehicles. Electrical vehicles you have, right? So what is the cost if you see compared to non-electrical vehicles? It is more than that. It is expensive. Similarly, the household, the electronic circuits, whichever they require DC voltage, if we use a battery and if you use that any circuit electronic device, so it may be get more expensive. That is one of the reason, and you have other reasons also. So that is the reason why we want to avoid this. So whatever may be the voltage which we are getting comparatively cheaper than these batteries, okay, cheaper than these batteries, we have to use, and that we have to convert into our DC voltage. So here the rectifier means the electronic device which takes the AC voltage or AC current, and it is going to be converted into DC voltage or DC current. That is what we call it as a rectifier here. Okay, the electronic device which is going to be take input as a AC voltage or AC current, and it is going to be converted into DC voltage or DC current. That is what we call it as a rectifier here. Okay, so in this rectifier, again, we have different types of rectifiers. We have different types of rectifiers. Like we call it as a half wave rectifier, full wave rectifier, bridge rectifier, and continuation of that one. So you have filters also. You have filters also. So then why we have rectifier is nothing but simply we are saying which is converting the AC voltage into DC voltage. So it is converting AC into DC. Then why we have this half wave rectifier, full wave rectifier, and bridge, and the continuation like filters? Can you tell?
We get pulsating DC output of the rectifier.
We will get
Pulsating DC
with the help of
rectifiers.
which rectifier?
Whatever rectifier we get pulsating DC. That's why we use filters to.
Okay. And in the rectifiers, what is the difference you have? Within the rectifiers, you are saying filters, it's okay. You are getting pulse width DC in rectifiers. I said that rectifiers itself like a half wave, full wave, bridge rectifier. So what is the difference between them? Do you know?
In optical rectifier, only about the cyclic will be used.
Yes.
And in forward bias, and
yes.
Reverse bias, it will be open.
Yes, yes, very. So if you see this rectifier actually it is an application of again a semiconductor device, which is a PN junction diode, One of the application of the PN junction diode, where we are using, you'll be doing PN, you will be studying about the PN junction diode as well as the Z0 diode you might be studied. So PN junction diode means you are going to be have a P-type material and N-type material which are sandwiched together. Okay. And in between this P and N type, you'll be having certain what we call depletion layer. We are going to be have. Why we are going to be get a depletion layer means in the case of the P-type material, the majority carriers are holes, whereas in the case of the N-type material, majority carriers are electrons. That means majority carriers are holes means you have the electrons as well, but more number you are going to be have holes. Whereas in the case of the N-type material, we say that majority carriers are electrons. That means you have the holes there also, but majority number you are going to be have electrons in the case of the N-type material. So if you take these PN junction diode, so this PN junction diode will be in this manner you are going to be. Suppose this is a P-type material and this is a N-type material which we have put together. So in between you have a what we call depletion layer you are going to be have. So in the case of the P-type material, we call it as majority carriers are holes we have been called. That means you'll be having this all more number of positive charges, less number of negative charges you are going to be have like this. Whereas N-type material, electrons are the majority carriers, whereas holes are less you are going to be have. So like this you are going to be have. So this is nothing but a PN junction diode we are going to be called. Diode, in the name itself, you have di, means it is having two electrodes. One is a positive, another is a negative, you are going to be called here. So when we take this PN junction diode, when we are going to be connecting any circuit, otherwise biasing in a circuit, it can be connected in any electronic circuit in two ways. How you are going to be connect a PN junction diode in any circuit? Yes, we can use this PN junction diode in a circuit in the form of a forward bias, otherwise in the form of a reverse bias. That means forward bias means this is what a P-type material which we are going to be connecting to a positive terminal of the battery, right? And this N-type material, whichever we have, this is going to be connecting to a negative terminal of the battery we are going to be connecting. So this is a positive we are going to be have, this is the negative. And this P-type material, what are the majority carriers you have? False, that is positive charges. And this is what you have? Positive. So there will be a repulsion in between these two. And this repulsion makes these positive charges to flow, overcome this depletion region. Right. Similarly, this is a negative charges are majority carriers in this N-type material. And this is the negative terminal which we have been connected. So there will be a repulsion in between this negative and this electrons. So automatically these electrons are going to be moved in this direction. That means they are going to be overcome that gap whichever it is having in between these two. That means that is the conduction of the charges is going to be takes place. So whenever the conduction of the charge is going to be takes place, the current is going to be flow. What do you mean by current? Flow of charges. Flow of charges. It may be positive or it may be negative. The flow of charges it is going to be occur. So that means when we connected, otherwise whenever we have connected this PN junction diode in the forward bias mode, so there will be a flow of charges when we supply certain voltage. So if you see the VI characteristics of this PN junction diode, this is the voltage and this is the current which we have. Right. So again, this junction diode, PN junction diode, either it can be made up of different semiconductors like germanium or silicon. Okay. So whenever we connect it in the forward bias mode, when we apply certain voltage, what will happen means it is going to be have initially zero current when we supply certain voltage. As we are increasing the voltage after reaching certain voltage, which we are going to be call it as what type of voltage it is? Threshold voltage. The current is going to be increases in this linear manner. So the threshold voltage is different for different semiconductors. For germanium and for silicon. For germanium around 0.4 electron volts. For silicon around 0.7 electron volts it is going to be have. So as the voltage is increasing at this point, due to the flow of these positive charges towards this and the flow of electrons towards this, they are overcoming this barrier and the current of the the conduction of the current is going to be takes place. So that is the reason why the current is going to be flow in this manner. So this is in the order of milliamperes it is going to be half. Okay. After reaching the threshold voltage, the current is going to be increases. Right. So this is about the forward bias of this junction diode. That is PN junction diode, whichever we have. And suppose if you take the same PN junction diode if you take, and if you connect this in the reverse bias mode, that means we are connecting the P-type material to the negative terminal of the battery, otherwise the source whichever we have, and this N-type material is connecting to the positive terminal we are going to connect. So automatically this is going to be have electrons are going to be moved. So this is the majority carriers are what? Holes. And here it is going to be move the positive charges, and the majority carriers here are electrons. So automatically what happens means there is an attraction between them, between the electrons and the holes, and between the holes and electrons. So automatically what will happen means these are going to be moved this direction, they are going to be attract, and this depletion region, whichever it is going to be half, it is going to be increases more. Increases more means the width is going to be changes more. That means there will be no flow of charges through this depletion region. So that means there is no flow of charges through this. That means there is no conduction in between these. So whenever we connect this PN junction diode in the reverse bias mode, you don't have any flow of charges. That means there is no flow of current in the circuit. So current will not be passed. So here if you see this reverse bias, so this is the forward bias VA characteristics we call. So here you have the reverse bias characteristics you have. In this reverse bias characteristics also, if you see, if you draw the VI characteristics, so you are going to be have certain current in this, which is in the order of microamperes, Whereas in the case of the forward bias, we have seen that due to the conduction, the current is going to be flow in the order of milliamperes. Whereas in the case of the reverse bias, as we are seeing, there is no flow of charges. That means there is no flow of current. Even though that, if you see the if you change the voltage of this battery, some current it is showing in the order of microamperes. We are saying that the depletion region has been increased. It has been increased. There is no flow of current. Even there is no flow of current, some current which is in the order of microamperes it is showing. What is the reason? Can you tell? Due to the presence of minority charges, and as well as due to the thermal agitation of this, the current which is flowing is in the order of microamperes. Okay, that is the reason you have. So I said that this is a very small current it is going to be flow. So this is about PN junction diode. So this PN junction diode, you have a lot of applications. As I told that it can be used in a what we call rectifier, one of the examples. And this PN junction diode, if you take in special condition, that we call it as what type of diode? Special case of PN junction diode, which is known as Zener diode. It is known as Zener diode. So you take this PN junction diode, and if you dope 1000 in the reverse bias mode, actually, you have to dope this PN junction diode in the reverse bias mode 1000 times more than this PN junction diode. If you dope, that we will call it as a Zener diode. We are going to be called. We call it as what? Zener diode. Okay. So this Zener diode, again, it is having certain applications. Direct application, one of the application is Zener diode can be used as what? Voltage regulator. So voltage regulator. So in order to regulate the voltage, that means if you are getting the voltage fluctuating, so if you required only particularly some voltage is required in any household circuit, only that voltage it is going to be give. Okay, that voltage only it can be give. So this is what the Zener diode application you have. Okay, so now we'll move to this half-wave rectifier. Why? Because this is the application of the PN junction diode. So generally, if you take any rectifier, it is going to be consisting of mainly three things, like from the output what we are getting, then where we have to give the input, and what circuit it is going to be have. So suppose if you take this half-wave rectifier, So if you see the circuit diagram of half-wave rectifier, see how many diodes we have used in the case of the half-wave rectifier. This is the symbol of PN junction diode. Only one diode we have been used. Simple circuit. So what we have in this? Input. This is the output. In between we have, what is this? What is this? Transformer. This is the diode. So then why we are using this transformer? What is the function of the transformer? Step down or step up. So here, this is what symbol of AC voltage. VI, whichever we have, this is the AC voltage, alternating current voltage. That means as it is changing continuously with respect to the time here. So this is what we have. So this is the time. So generally we will represent with omega t of t. So this is the voltage. So maximum V maximum we will call here. So if you see, as the time is changing, it is continuously changing. Initially at this point, at 0 degrees, at this point it is 180 pi we are going to be called. This is a 2 pi. So this is one complete cycle. One complete cycle, 0 to 360 degrees, one complete cycle it is going to be have. So 0 to 360 degrees with respect to the time, it is going to be changes continuously. That is what we call it as a alternating current. So this is the input. So what is the input we have from the outside? To your home it is coming. What is the voltage it is getting? Alternating voltage only. What is the voltage? 220 to 240 or 250 voltage. Again, the power generation where it is going to be happen. We have certain specification. Okay. In our India, the power generation, it will be done with this much of voltage, which we are getting into your households. That is around 220 to 240 voltage. And with a frequency of 50 hertz, it should have 50 hertz frequency. So if you move to other country, you may not have the same. They may be producing some 100 or 110 volts with some other frequency. Okay, depends. Okay, so in our India, the voltage which we are generating means which is coming to your households is around 220 to 240 volts. That is a not constant one. It is fluctuating in between these two and it with a frequency of 50 hertz. So this is what we are getting here. Here, this we have to connect to your electronic device, which is having certain voltage. Okay, which is having certain voltage, DC voltage, maybe whatever it may be. So this is what you are getting. Say that you require certain 20 volts of DC you required. What is that? 20 volts of DC you are required. But you are getting how much? 220 volts you are getting. So first of all, this voltage, we have to get down. We have to get down. That is why we are using it as a transformer in between here. What is the function of the transformer means? It can increase the voltage. It can decrease the voltage. Step up the voltage, step down the voltage. Suppose you require 20 volts of DC. So initially we will make this 220 volts to down. We will use this step down transformer. So where the number of primary turns are greater than the number of secondary turns. Transformer. Suppose you require a DC voltage more than this. Say that 220 volts you are getting. Suppose you require some 300 volts of DC voltage if you require. Then we'll use step up transformer here. Okay. So the input here is the AC voltage, and here you have a transformer. Depends upon your choice whether it be required step down or step up. We'll be using the transformer. And that voltage after getting step down, say that for 20 volts. So this will be given directly to a diode. Okay, diode. And this diode is going to be perform something, and you are going to be get DC voltage we call here in half wave rectifier. So input voltage, if you see, this is what we have. This is the input voltage, B input. Okay. V output, here you have some, sorry, V input. This is a maximum peak, whichever we have, right? So now, initially, when this voltage entering into this diode, so this positive half cycle, initially it is going to be entered. Okay, positive half cycle. This is the 0, the above whichever we have the positive half cycle, the below whichever we have the negative half cycle. This above positive half cycle, this will be entering to the diode. What is the diode function? As we have seen, whether it may be in the forward bias mode or reverse bias mode. Whenever the forward bias mode diode, it is going to be conducts the current. Whenever it is in the reverse bias mode, it does not conduct the current. So here, during this positive half cycle, when it is entering to this diode is going to be in the forward bias mode. How? This diode is going to be in the forward bias mode. So automatically, whatever may be the voltage which is coming into the diode, it is going to be conducts. So here, this is the output voltage we say. So this part, whichever it is there, it is coming out. Okay, which is coming out as the output. Then after positive half cycle, the negative half cycle, whichever we have, this is going to be enter into this diode. Negative half cycle is going to be enter into the diode. Whenever this negative half cycle is entering into the diode, this diode is going into the reverse bias mode. It is going into the reverse bias mode. That means this part of the cycle of voltage you won't see in the output. So it is going to be missed at this point. It is going to be missed at this point. This is over. Again, after completing this full cycle, next another cycle is going to be enter, which is having the positive half cycle. Again, during the positive half cycle, what happens? It is going to be enter in the output. Why? Because the diode is going into the forward bias mode. This is you are going to get. Then after what you have? Negative half cycle. This diode is going to be into the reverse bias mode. So there is no output. So this is the input voltage which we have been given. This is the output voltage which you have been given. Right. So if you observe this output voltage, so if you calculate like how much DC voltage there, how much AC voltage there in the output, okay, we can get this. So generally, this half-wave rectifier, it is going to be have the efficiency. What is the efficiency of the half-wave rectifier? It is 40.6% only. That means almost half it is missing. Efficiency is this much. Efficiency means output by input. So what input we are getting, whether we are getting in the output or not. That is what we call it as efficiency, output by input. So only 40.6% you are going to get. That means very less efficiency it is having. Then you can calculate the ripple factor also. For the calculation of all these things, you have mathematical calculations. That means this representation of the sine voltage, V input can be written as a V maximum sine omega t we can write. Vn sine omega t we can write. And similarly, what is the output we are getting? We will write with the help of that one. We are going to be calculate this all like DC current, efficiency, ripple factor, all those things you can calculate. So actually, what do you mean by ripple factor means? In the output, how much AC is there, how much DC is there, this will tell by what we call ripple factor. In the name itself, you have ripples. This one, ripples. Okay. So generally, the ripple factor of this half-wave rectifier is 1.21. It is 1.21. That means the voltage is converting not completely into the DC. The voltage is not completely converting into the DC. Actually, DC should be like this. But you are getting some ripples. So, rectifier, we said that the DC voltage or DC current is going to be converting into a AC voltage or AC current is converting into a DC voltage or DC current. But it is not completely converting. Only some part it is converting. Because efficiency is, ripple factor is more. 1.21 you have. So that is the reason why we have another rectifier, which we call it as a full wave rectifier. So we said that it will convert AC into DC, but it is not completely converting. Some part it is missing. Okay. So we are using half-wave rectifier one diode, so that efficiency is this much, ripple factor is this much you are getting. So now we'll move to the full wave rectifier. Why we getting full wave rectifier means some drawback is there in the half-wave rectifier, so that we'll go for full wave rectifier. So in the full wave rectifier, how many diodes we are going to be used? 2 diodes. So generally the full wave rectifier should be center tapped. Okay. This is the diode 1. This is the diode 2. So the 2 points which we have. This is the center tap. So again, same input we have. So after stepping down the voltage, again, whatever may be the step down voltage, depending upon the requirement, how much that is going to be stepped down, and that voltage is going to be flow into these diodes. So in this case, as I told, that input is consisting of positive half cycle and negative half cycle. So this is the half-wave rectifier output, whichever we have, this one. Then we'll move to the full-wave rectifier. Right. So during this positive half cycle, as I told, that diode D1 will be in the forward bias mode, and second diode D2 will be in the reverse bias mode. That means the current will flow through this one, the current will not flow through this one. So as this is the input, this diode conducts, this diode does not conduct. So the output here you are going to get at this point. Okay. And negative half cycle, whichever it is having, when it is entering into these diodes, so this diode does not conduct, the first diode, second diode is going to be conduct. During the negative half cycle is entering into this one. So again, this part, whichever you are going to be have, this is going to be get at this part. Okay. And again, it has been completed one complete cycle. Again, next cycle it is going to be get. Same thing. During the positive half cycle, the diode D1 conducts, during the negative half cycle, diode D2 conducts. Therefore, this part is going to be here. Right. So whatever we are missing in the half wave rectifier, we are going to get in the full wave rectifiers. Full wave rectifier. So mainly in this full wave rectifier also, if you see the efficiency, what is the efficiency for the full wave rectifier? 80%. Efficiency is 80.1 or 81% you are going to be have. So what is the efficiency of the half wave rectifier you have? So has been doubled or not? Doubled. As we have used two diodes, the efficiency has been increased. And as well as the ripple factor. What is the ripple factor you have? 0.6. So 0.6. What is the ripple factor of half wave rectifier you have? 1.21. Has been drastically decreased or not? What is the ripple means? Ripple factor means the percentage of AC voltage which is there in the output. In the previously it is very high. When we have used this one, it has been come to 0.6. So that is the why we are avoiding, we are taking a full wave rectifier instead of a half wave rectifier. Okay. So this is what main difference you have. Efficiency has been increased 100% and this ripple factor also decreased mostly. So 0.6 like that it has been decreased. So this is about full wave rectifier. So even if you want to, you have like a bridge rectifier. So you have a bridge rectifier. So in the case of the bridge rectifier, how many diodes will use? 4 diodes we are going to be used. Okay. So there, during this positive half cycle, alternatively, you are going to be conduct 2 diodes, D1 and D3. Whenever the negative half cycle is going to be enter, the diodes D2 and D4 you are going to be conduct. Diode D2 and D4 is going to be conduct. And you are going to get almost this only. Maybe efficiency increased, but very less. Around 5 to 10% it is going to be increases than the full wave rectifier. Even the efficiency also don't have much difference in the case of the bridge rectifier. A small change. Okay, so that means when we are using these rectifiers, whether it may be half wave rectifier, full wave rectifier, or bridge rectifier, in all these 3 cases, the voltage, the output voltage, which we are calling it as a DC voltage, completely we are not getting the DC voltage. Some part of the AC voltage is present there. Understand? In the case of the half wave rectifier, or full wave rectifier, or bridge rectifier, the difference may be there. Half wave rectifier, you have a lot of AC in that component, whereas full wave rectifier, reduced AC component, you may be having more DC is there. Even in the case of the bridge rectifier also, you may be having the lot of DC, less AC you may be having. But still AC component is present in all these rectifiers. But we required a pure DC is required in order to work certain electronic devices. So for that reason, so we will be going for filters. Filter circuits we are going to be get. So filter circuits are so nothing but by using this half wave rectifier, full wave rectifier, or bridge rectifier, we are going to be connect some extra components in that, and we calling it as a what we call filters. Like you may be having what type of filter? Capacitive filter is there. Inductive filter is there. Pi-section filter is there. Okay. Capacitive filter means at this point, we are not taking directly through this output. We are going to be connect one capacitor at the output. After passing this voltage, it is going to be into this capacitor and it is giving out the voltage. Almost you have the DC, some very small component of AC, around some 0.1 or 0.2%. Okay. So almost you are going to get this. With the help of the half wave rectifier, we can get this capacitive filter. Half wave rectifier capacitive filter will come. Otherwise, full wave rectifier, if you connect a capacitor, we call it as a full wave rectifier filter we are going to become. Sorry, full wave capacitive filter we are going to become. And by using this inductor also, okay, inductor, at the output we are going to be connect, and we can reduce this ripple factor. And we have a pi section filter. Pi section filter means you have one capacitor and two capacitors and one inductor. This is what we have at the output. So with the help of these filters, we can reduce the AC component in the output to 0. Okay. So this is how we work the filters. So in how the half-wave rectifier is working, what is the working we have, what is the working of full-wave rectifier we have. So why we are going to be use the filters means in all these rectifiers, we have some AC component in the output. So to avoid that one, we'll be using these filters. So filters, why we are going to be used means in order to completely get the DC voltage, 99% you are going to get the DC voltage in the output. Okay, so that is how filters are going to be work. Okay. So if you have any doubts, you can.
Yeah. Anybody? You have any doubts? If you have any doubts? Yeah. Now, vote of thanks by Ashwini sir.
A very good afternoon to all of you. I would like to first. Very good afternoon to all of you. First of all, I would like to thank our HOD madam, Mrs. G. Pushpa Sakrapani, who is not only HOD but Faculty of Science also, who has organized such a beautiful lecture here, which was very knowledgeable, and we have got complete knowledge what is the importance of electronics in our daily life, and with different things we are using, but we did not know how they are working. And basic component which we need is batteries, power supplies, and what are the different terms required for the power supplies like rectifiers and the different types of rectifiers. Everything we have understood very much. So I am very much thankful to you, sir, for coming here and delivering such a beautiful and clear lecture. We are able to understand each and every term here now. Thank you.